Hello, this is Bill. So I'm back. We've got the Chapter 5 of the IT Fundamentals ITF Plus certification series I'm doing. I did skip Chapter 4. I will come back to it. So an operating system is the one of the primary things it does is provide the human interface that we can use the computer. This is what you see when you boot up your computer and you see all the graphical interface, all the icons. You move your mouse around, click, double click, copy files, move files. This chapter will discuss 4 operating systems at the very highest level. And I will vary from your book on this one here. So just keep that in mind. This certification will discuss Windows, Apple's Mac OS, Linux, and the Chrome operating system. We call the operating system, or the OS, that again provides your human interface to the computer. This is where you can enter your commands and the computer responds. It's a layer of software that enables the hardware and the applications to work together. Without the OS, things like word processors wouldn't work. There are 4 parts to an operating system. A way of displaying our structure of data, or these are the file folders, the files. You can copy, move. This is your file structure. We coordinate various hardware components. You've got your screens, your printers, memory, CPU, all these I/O devices. The operating system coordinates the operation of all of that. And we provide an environment for the software to function. So without the operating system, word processors, spreadsheets, web browsers wouldn't run. And finally, the operating system monitors the health of the computer system itself. So your operating system, in terms of its functions, it displays structure, displays your data, allows you to monitor and view those files, allows you to organize those files into logical data sets. Pictures are stored in one area, documents in another area. You can create directories for projects and move all the files and documents and you want into those directories. You can copy, move, rename, delete, do a whole lot of things with that within the function itself. We coordinate, again, our hardware components, our hard drives, memory, CPU, I/O, input devices, or all that are managed and coordinated by the operating system. Provides an environment for the software to function. So we're managing memory, CPU, the graphical user interface, or the command line interface. We'll discuss those at the highest levels a little later in this chapter. And we monitor a computer system the operating system monitors the computer system for health and functionality, checks the hard drives for errors, checks for malware, monitors your memory and CPU, and finally monitors I/O devices, keyboards, mice, printers. There are 3 characteristics of the operating systems in this exam: licensing, software compatibility, and complexity. Licensing, there are 3 models of licensing: open source, free, and commercial. Open source licensing is software anyone can download, run, and modify the software. Free software from open source software is free for most people and organizations. You will find some open source licenses that will say that if it's run by a government or if it's run by a large corporation, there's a charge. Most open source software is free for anyone to use, modify, and run. So just keep that in mind. But there are some software licenses, you got to read them, that say government agencies or large corporations cannot use them. Open source software is owned by an organization, so it's actually, you go out there and you see this open source, someone owns it. There's a license for it. It's might be an individual, might be an organization. However, that owner is letting people download the software, modify the software, and run the software for free. Open source software may not be supported or guaranteed by the organization that owns it. So just because someone builds the software, throws it out there on the internet and says, hey, please download it and run it, doesn't mean they're going to support it. So just keep that in mind. There's many times no or limited support for open source software. After open source software, the next model is of our licensing discussion is free software. Now, free software is not necessarily open source. The open source, you're getting the software. You can download the software and run it, but you also have the capability within open source of seeing the source code, seeing how it was written. You can modify that source code if you desire. We'll say you download the Firefox browser, and there's something you don't like about it. You can actually get if you're a programmer, you can get that source code, and you can modify what you don't like about that Firefox browser, and then rerun it with those modifications. You can also upload it to a website where someone else might be able to download your changes. That's open source. The source code is open. People can modify it and make changes to it. You may not get access to in fact, in free software, you do not get access to the source code. Again, the Chrome browser and Chrome operating system are owned by Google. Google allows users to download those and run them without charging. And finally, we have commercial software. This software is privately owned, and the company may charge to use that operating system. The commercial software frequently comes with an end-user license agreement, or EULA, E-U-L-A, that you've got to agree to before the software can be used. Public cloud providers such as Amazon, Microsoft, and Google allow you to take these licenses for this paid software and run it in the cloud. This is called the bring your own license model. The second part of an operating system that we're worried about is software compatibility. When software is written, it's written to work with a specific operating system. For example, when you buy a piece of software, we'll say Microsoft Office, for the Windows environment, that Office application is not going to run in the Mac OS or in Linux. It'll run fine in Windows. Just again, if you try to port it into the Mac or to Linux, it will not work. If you want to run Microsoft Office in the Mac environment, you're going to have to purchase the Macintosh version of Microsoft Office. Before purchasing software, make sure that it'll work with the operating system that you are running. And in some cases, you have to make sure it works with the version of software you're running. For example, the Mac OS software written for Mac OS version 9 will not run in version 10. So verify that the software you're purchasing will work with your specific version of the operating system. So not just the operating system itself, the overall arching, Windows, Mac, Linux, Chrome. Make sure that it works with that version that you're running. And next we have software complexity. Modern hardware has two versions of the CPU, 32-bit and 64-bit. Operating systems have also two versions, a 32-bit and 64-bit. A 64-bit version of the operating system will not run on 32-bit hardware. Now, the four operating systems that you should be familiar with for this exam are Microsoft's Windows, Apple's Mac OS, Google's Chrome OS, and Linux. At this point, I'm going to vary from the way your book covers it. I encourage you to read the book. The book covers it in a fashion that talks about different versions of Windows and how they look and feel. So again, I encourage you to read that part of the chapter. Microsoft Windows largely is a graphical user interface. It does have some command line interface options. So Microsoft Windows is the most popular operating system in use today. If you walk into most businesses, you'll find some version of Windows running on most desktops. Windows is a 64-bit operating system, and it does require 64-bit hardware, 64-bit CPU. It supports both 32-bit and 64-bit software. It does not support 16-bit software. Windows has multiple versions and editions. The Windows 11 editions are what you're typically going to run on a laptop or a desktop. This includes Windows 11 Home, which is what you're probably going to buy when you say go to Best Buy and buy a laptop or desktop for your home use. It comes with most PCs that are bought by the general public. Windows 11 Pro includes all the features of Windows 11 Home, but it also supports BitLocker, which is used for hard drive encryption, a remote desktop, and the ability to join a domain. Most organizations run Windows 11 Pro or Windows 10 Pro. Windows 11 Pro for workstations is, again, Windows 11. It is for workstations. A workstation is a computer with advanced hardware. Used to do real high-end work with, say, computer-aided design, graphical processing. It's very high-end workstations. And Windows 11 Pro for Workstation, again, has all the software capabilities of Windows 11 Pro, but it also is optimized for these workstations. Other editions are Windows 11 Pro for Education and Windows 11 SE. Microsoft also publishes a Windows Server edition. Now, the Windows Server is designed to support business processes and multiple users. Typically, users don't log into a Windows Server like they would a desktop. A server sits in a back room somewhere in a computer room in a data center, and people use the applications that are running on the server. Windows servers run applications such as web servers, streaming music, file services, email, and a whole host of other software. Windows Server editions include Windows Server Essentials. This is designed for small businesses with up to 25 users and 50 devices. The Windows Server Standard is the most common one probably used today. It's suitable for most businesses, provides a wide range of features and capabilities. Windows Server Data Center is designed for large-scale deployments in data centers using advanced features. Again, you don't have to go into what those features are. And keep in mind, each of these editions comes with different licensing options and pricing structures. So before you go out there and buy a Windows Server edition, make sure you understand your needs and the features of each particular operating system or version, and make sure those needs meet the needs of the business. Apple's Mac OS is a popular operating system. It's not as widely used in business, but it's still relatively common. It runs on 64-bit hardware, in other words, a 64-bit CPU. The recent versions of the Mac OS have phased out support for 32-bit applications. So at this point, if you're buying a newer Mac with the latest Mac OS, you're only going to be able to run 64-bit applications. The Mac OS is Apple's proprietary operating system that powers its entire Mac lineup, from MacBooks to iMacs, Mini Macs, Mac Studio. It's got a sleek design, user-friendly interface, robust security features, seamless integration with Apple devices like iPhones and iPads. Apple does not have a server version of the Mac OS. Linux is an open source operating system that has a whole lot of different versions and different features. These different versions or distributions are also known as distros. So a lot of times you'll say, hey, what distro you're running? They're talking Linux, and usually they're talking about the different versions out there that are put out by different companies. So you'll have, say, Red Hat Linux, Ubuntu Linux, Mint. Those are all different distributions of Linux. Each distribution is put out by a different company and with slightly different features and different interfaces. And some of the commands that they put out in the CLI are different from one distro to another. So just keep that in mind. They're not interchangeable. Linux can be run as a graphical user interface or command line, or in some cases, like Windows, they use both. But you'll find that a lot of times the Linux, especially in the data center, is run with a command line interface and not the graphical interface. Linux supports both 32 and 64-bit hardware. Most distributions are currently 64-bit. However, you can still download and run 32 bits. If you have an older laptop and you want to run, you can find it. Linux is very highly customizable. It supports different desktop environments, different hardware, and different applications. It runs on pretty much anything I've seen in terms of laptops and desktops. Linux does have a longer learning curve than other operating systems. If you're going to run this, you're going to have to take some classes in it. Yes, if you run just a graphical interface and you're comfortable within Windows, you can probably do okay within the GUI. But if you have to go on that command line interface, it is different. And even within the graphical user interface, downloading and getting applications to run, sometimes is straightforward, sometimes not. So there's a longer learning curve. There are both desktop and server versions. The Linux server versions include Ubuntu Server, CentOS, Debian, and Red Hat Linux, or Red Hat Enterprise. The Chrome OS is distributed by Google. Chrome OS is free, however you need a compatible device such as a Chromebook to run it. It resembles Google's Chrome browser. Most of its apps are web-based and tied into the user's Google account. Apps are installed using the Google Web Store. The operating system is designed to connect to the internet. It's not designed to be standalone. Windows, Linux, and Linux can both be run standalone without the internet. You can install word processing applications, spreadsheets, whole host of applications on a Linux or a Windows laptop and have it not connect to the internet, and it works just fine. That is not the case for Chrome. With Chrome, you have to be connected to the internet to get full use of it. So, of the 4 operating systems we talked to, Chrome OS does require an internet connection to get full functionality. Windows, Mac, and Linux do not have that requirement to be connected to the internet. Most Chrome computers have a real small hard drive, and you rely on Google Drive for most of its storage. All operating systems have certain common features. First, all operating systems are designed to run programs or run apps. Now, apps can be run manually or they can be scheduled. An example of a scheduled app would be a backup. So you want your system backed up at midnight when no one's using the system. So you want to schedule that. You don't want to come in at midnight and run the application. We want to schedule it. So in the Windows environment, we use a process called Task Scheduler. In the Linux environment, we use a process called cron. And both the Windows Task Scheduler and the Linux cron, or the Linux cron job, as some people will call it, can be used to schedule an application to run at a specific date or time into the future, or on a regular basis. Within a graphical interface, we can also run an application by just simply double-clicking the application's icon and the application runs. In a command line interface, we have a command prompt and we enter the program's name, press the enter key, and the application will run. Other ways to run programs are with keyboard shortcuts. You program these into your keyboard and you press the special key combination and the application will then run. You may also run an application by clicking on the associated data file. For example, if you click on a .x docx file, that will automatically run the Microsoft Word in Windows application and load that file with it. In a secure environment, the user might need permissions to run a certain application. Now, a special user called an administrator will grant the permissions to run that application. So if you're in one of the secure environments and you double-click on an application and it does not run, you may have to call the administrator and get permission to run that application. Some programs, and I've mentioned this kind of real quickly in the last slide, are what are called services. These services run in the background. Most of the time you never really see them. They are they're either called services on Windows or daemons in Linux. Common services are antivirus applications, backup, and security software. Services or daemons usually start when the computer starts, and it doesn't have to be run by the computer's user. It's an automatic process that just starts. You can increase your performance and security by removing unnecessary services. Keep in mind, these services are programs. As programs, they use CPU and they use memory. So if you are not needing, for example, if you don't need to back up your computer for whatever reason, maybe your data is all stored in the cloud, so you don't need to back up your local workstation, remove the backup software, prevent it from running. That backup software is not going to use your CPU and not going to use memory. So just keep that in mind. It's one of those situations. If you can stop running an application, you're going to get more efficient use from your other applications in terms of CPU and memory utilization. And when you're running these applications, these services or daemons, they can be attacked. So if there's a vulnerability in one of those applications, someone out there can take advantage of that. If the program's not running, your attack surface is reduced, and that's just basically reducing the number of applications that are on your system that can be attacked. Operating systems manage hardware, and one of those things you can do is manage files. So within Windows, we have an application called Windows Explorer. In the old version, it was File Explorer. These are used to manage files. The Mac OS uses a program called Finder. Linux uses a file management program called Files. And in Chrome, you can use the File app to manage your files, or you can access your Google Drive and manage the files within Google Drive directly. Now, your operating system is a piece of software, and it's going to have to run on hardware, and it's going to have to manage all this different hardware. So we need the operating system needs to communicate with this hardware in order for the computer to work. And all the hardware in computers is different. Hardware is updated. You might be running a network interface card right now at 100 megabits, and you go out there and you buy a 1 gig card. It's different hardware. It's updated. It's newer. Hardware is made by different manufacturers. Hardware made by Hewlett Packard is going to be different than hardware made by Dell. It's just going to be different. So they're using different electronics, different ways of doing things, and hardware has different functions. Printers print, video shows video, hard drives use storage, and your operating system has to communicate with all these different things. And the way the operating system does that is by using what are called device drivers. Device drivers are that intermediary between the operating system and the hardware. So most hardware today is plug and play. What we mean by that is you plug something in and the hardware just seems to be recognized by the operating system. What happens when that in a plug and play environment, the hardware reports its specifications to the operating system, and the operating system assigns resources and installs the device driver or drivers. If the operating system can't find the device driver, it will prompt the user of the computer to insert a disk, a thumb drive, or download the driver. It'll ask, where is this driver? Where can I find it? And basically point it to that location, whether it be a thumb drive, maybe you've downloaded on a hard drive. You might have a system with a CD-ROM or a DVD drive, and it could be on a DVD disk, or you might have to download that from the internet. All major operating systems today support internet connectivity, whether using Ethernet, Wi-Fi, or a modem. So just be aware of that. All of them do at this point. Hotkeys. Hotkeys are keyboard shortcuts that enable a user to issue commands using the keyboard. So you don't have to necessarily use your mouse for everything. Applications may also have their own shortcuts. In the Chrome operating system, keep in mind applications are tabs in a browser, or at least that's the way they appear. So here are some sample shortcuts. If you want to shut down an application in Windows, make sure the application is active and hit Alt F4. The Macintosh OS, it's Command W. In Linux, it's Control Q. In Chrome, it's Control W. So these are some of the hotkeys you can have with the systems. One key thing in here is remember the open help. In Windows, it's F1, Command $? in Mac. Linux does not have help from the operating system standpoint, and Control $? for Chrome. Screen captures or screenshots. This is a digital representation of what was on a screen at one point. So basically, it's a graphical image of a screen. Most operating systems have shortcuts for this capability. Unfortunately, some keyboards don't have the print screen. My keyboard here at home, for example, does not have the print screen button. I've got 3 buttons that are programmable on this particular keyboard. It just doesn't use that print screen. So within Windows, you hit the print screen button. That is by default stored in the pictures, screenshots location. In Mac OS, you have Command Shift 3 to capture the entire screen, or Command Shift 4 to select an area on the screen. That is stored by default in the desktop. In Linux, you hit the print screen button, and in Chrome OS, you hit the control switcher button, and the locations are stored. Accessibility options are features within an operating system that make it easier for people with disabilities to use the OS. These are accessibility options, and they fall into 4 categories: movement, visual, audio, and voice. Movement helps with limited dexterity. Visual are features that help with people with limited vision. High contrast screen, extra large mouse buttons, screen reading programs. Audio helps with people that have limited hearing, and voice are programs that can help with voice commands. When they say audio helps with people with limited hearing, for example, instead of a bell chiming in an application, a light might flash or an LED might flash. To find these accessibility options within Windows, you're going to go to the Control Panel, click on Ease of Access, and click on the Ease of Access Center. In the Mac OS, it'll be System Preferences and Availability. In Linux, look under the Universal Access. Linux it may vary from version to version. And the Chrome OS, you're going to go into Settings and Accessibilities. That's it. It's a short chapter, not a whole lot going in there. The authors of the book do cover the operating systems in a lot more detail than I did.